Telescope. When we go out on a starry night, we see stars and the moon shining in the sky. Sometimes we wish to have a closer look of these heavenly bodies, but is it possible with our naked eyes? No. To fulfill our desire, we have a device called the telescope. A telescope is an amazing device which has the ability to make distant objects appear much closer. There are mainly two types of telescope, classified on the basis of their use. First is the astronomical telescope, which is used for seeing celestial bodies like moon, sun, and planets, etc. Secondly, we have the Galilean telescope, also used to observe celestial bodies, but it gives an erect final image. Let us see in detail how these telescopes work. Astronomical telescope. An astronomical telescope consists of two convex lens systems mounted coaxially. The lens system facing an object is called objective, and the other lens system facing the eye is called eyepiece. The objective of a telescope has a large aperture and a large focal length FO. It collects more amount of light from distant objects and forms a bright image of the object inside the telescope. An eyepiece lens of small focal length FE and small aperture is used to magnify this image. Now let us see how this assembly works. When a parallel beam of light rays from a distant object falls on the objective, a real inverted and diminished image A-B- of the object is formed at principal focus of the objective. Now, separation between objective O and the eyepiece E is so adjusted that the image A-B- falls within the focal length FE of the eyepiece. The eyepiece forms a virtual and magnified image A"B" at the least distant of distinct vision. In practice, the distance between the objective and the eyepiece is so adjusted that the first image A"B" falls on the focus of eyepiece, and final image is formed at infinity. In this case, the telescope is said to be in normal adjustment, and the eye experiences minimum strain. Here, the final image is inverted, but this does not affect the observation, because the objects are round in shape. Magnifying power. In normal adjustment of the telescope, the magnifying power M is given by M is equal to FO upon FE, equation 1. Further, the distance between objective and the eyepiece, that is tube length L of the telescope, is equal to the sum of their focal lengths. Therefore, L is equal to FO plus FE, equation 2. From equation 1, it is clear that for increasing magnification of the telescope, an objective must have a large focal length, whereas an eyepiece lens must have a short focal length. Galilean telescope. As we know that in case of an astronomical telescope, we get an inverted final image, but it is not very useful to have a magnified but inverted image of a tree. To get rid of this difficulty, a Galilean telescope is used, which gives an upright final image. In a Galilean telescope, a converging lens of long focal length FO is used as an objective, and a diverging lens of short focal length FE is used as an eyepiece. Let us see how a Galilean telescope works. As parallel light rays from a distant object falls on the objective lens, a real and inverted image A-B- is formed at the focus of objective. Now, the eyepiece lens is adjusted in such a way that the image A-B- falls on its focus, lying on other side of the eyepiece. Due to this arrangement, a final upright image is formed at infinity. In this case, the distance between two lenses is equal to the difference in their focal lengths. Therefore, tube length L is equal to FO minus FE, equation 1. And the magnification M is given by FO upon FE. Thus, Galilean telescope not only provides us with an erect final image, but its tube length is also shorter as compared to the astronomical telescope. However, the field of view for Galilean telescope is smaller than the astronomical telescope.